there is a basic structure to writing SQL commands. So like I explained the last time, a SQL statement simply consists of reserved words and user-defined words. The reserved words are a fixed part of the SQL language and have a fixed meaning. Also, they must be spelled exactly as required. They cannot be split across lines, whereas user-defined words are made up by the user. Now, these words usually represent the names of various database objects. Usually, it is the column names that you would find mainly as user-defined words. Now, SQL is case insensitive, which means that if you look here, for example, look, if you see my cursor, if you cannot see my cursor, you can just unmute and say you can't see it. You see that I've written select in uppercase, and I've written the other bit in lowercase. It doesn't mean that that part has to be uppercase by all means. No, it doesn't mean select has to be written in uppercase. Select can still be written in lowercase and it would work perfectly fine. So SQL is case insensitive. However, there is an exception to this rule. Now, this exception applies to what is known as literal characters or literal data in the database. Now, these are the records that are stored, how the records are stored in the database. So, for example, if you store the name Smith as capital S-M-I-T-H, but you search for it as capital S, lower M-I-T-H, you will not find this in the database because SQL will not recognize this because you have not stored that data as this. You have rather stored it as that. So SQL will not recognize it. Now, though we say that SQL is it's a free format language, you can write it mainly in anyhow that you please. However, there is a format, there is an order that it would have to follow. And that's just because we want to have good practice. That's for good practice. Now, each clause in a statement should begin on a new line. The beginning of each clause should line up with the beginning of other clauses. If a clause has several parts, they should each appear on a separate line and be indented under the start of the clause to show a relationship. Now, what are the major data manipulation commands in SQL? Those are what I've listed here as select, insert, update, and delete. These are the major data manipulation commands in SQL. However, the select command is the most commonly used. There is no other SQL command that is as used as the select command. I think I've already explained literals, but let me just use this as an example. So, yeah, so if we have literals, for example, those data objects that you have stored in the database, like all these ones, these are the data objects that you have stored in the database. Now, string data are stored in single quotes. String data are stored in single quotes, whilst integer data do not require a quote. Numbers don't require a quote, but string data require a quote. So what is the format of a simple SQL statement? The format starts with the select command, followed by from, then it goes to where. The select shows the table or tables that you want to, it shows what you want to pick from. So select shows exactly what you want to do. From shows the table that you are going to select your data from. And if there are any conditions for this select command, it comes under the where command. If you want to group your data, you use the group by. If you want to have a condition on your group, you use the having. And the last part of any SQL statement is the order by statement. Now, these first two, select and from, are mandatory parts of any SQL statement. The others are used as and when needed. So we don't need to use a where, we don't need to use group by, having, order by, we don't need to. However, depending on the kind of query that we want to run, we might need to use these things. Right. So I think I've explained all of these. Now this this just summarizes the brief introduction. So let me go to the SQL server, and then let's see if we can run a few queries. But before we do that, I want to show us what is in the database and what we shall be using. This is a database. It has two main sets of data. The HR, SQL HR, which contains tables, and those are the tables that we are interested in. Those are the tables that we are interested in. These are the tables. These ones here, that's what we are interested in. There is another table here, but we might not use that today. We don't need that today. So I'll just close that. This is what we are interested in today. Now, we are mainly interested in the employee table. So let me see if I can open it quickly so that we can see what it has. Select. I'm just going to run I would explain this in a bit. Employees. If we run this, okay, so you see that there's an error here. Now that tells me that something is wrong. It simply means that I haven't chosen the right table, or I've chosen the right table, but I didn't select the table from the right place. And if you hover over it, it says invalid object's name. So I come here and then I select, it's under this table is in this database. So I need to change that to that. and then that should adjust. So if I run this, I think I did this last Saturday, was it over the weekend? This is the employee table. So we will be needing these column names in running our queries. That's why I opened it, so that we know exactly what we are looking at. Right now, there are two ways by which we can open up this table. One of them is to select each column name. So instead of this here, this is what I intended to be the second bit. We can select this by each of the column names. So select. We want to select everything to retrieve everything. Let me call it query 1. To retrieve. Did I spell that right? No. To retrieve all columns. Select. What are the column names? The column names are person ID, person ID, person ID, followed by a comma, employee, employee number, followed by a comma, start date, end date, title, forename, surname, birth date, gender, then the next one is address ID, date time added, and then date time modified. I hope I got everything. Right. So we have this, select everything. We are selecting all columns. Where do we want this? Where are we selecting this from? We are selecting from employees, the employee table. That is where we are selecting this from. Right. So if we run this, we will get exactly what we got here. There will be no change at all. See how many columns we have here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. If I click on execute to run this query, there will be absolutely no change. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it makes sense.
Can I pause you for a second?
Yes, please.
Yeah, how did you know that this is employee table, is there anything that tells you what table you're on?
Oh yes, I selected, that's the aim. That's what I wanted to do.
Okay. Oh, right. Okay. Thank you.
So it makes sense to use the asterisk, the star. So what this simply means is that select star is also read as select all. Select all. Right. So this is one way by which we can select data from a table. This is another way where we want every bit of data. Then we use either this one or that one. However, we can restrict the number of columns that we want. Instead of selecting everything, why select everything if there is data that you don't need? So let's say we restrict columns. You just select the columns that you want. Did I get spelling of restrict correct? Restrict selected columns. Okay, yeah, I know what happened there. Again, you see that there's a red line here. Simply what this means is that SQL doesn't recognize this because it is not a word in SQL anyway. So I just wanted it to be a comment. We can select some of this. Let's just select a few of this. Let's not select everything. It's a bit of waste of time if we select everything, isn't it? From employees. Right? So again, we have this, and if we run this, then we are going to get only 1, 2, 3, 4 columns. So let's run this and see. We get only 4 columns. 1, 2, 3, 4. Right? Pretty straightforward, pretty simple. Okay. Now, another thing that's SQL's certain what should I say? Is certain servers would use, or certain databases, is that they expect at the end of the statement you can put a semicolon. It will still run the same. With or without it, it will run the same. So let's run it and see. Nothing happens. It's the same thing. So it is. That's why we say SQL is free format. It's very, very flexible. Those who were here on Sunday, you remember I said if you go into an organization and you do not know what is in the database, for example, if this was like they used Facebook as an example that time, if you are to query the whole, say you want to select all posts on Facebook, the system will crash. You can't do that. The system will crash because you do not, the system may crash. Let me not say will crash. You don't know the volume of data that is in that database. So it is not advisable to run this command. It is not advisable to run unless you know exactly what is in the database, or unless you are instructed to run everything, meaning that somebody somewhere knows that that is a safe thing to do. So it is not safe to just go and start running this command if you do not know the volume of data that you have in the database. So one way, if you go into an organization and you just want to query the database, and you know the different tables in the database, you can restrict the number of rows. You can restrict the number of rows that you call, just as you can restrict the number of columns. So here too, how do we do that? Let's see. Restricting the number. Restricting the number of rows. So let's say we select top 7 of all. Select top 7 of all from employees. Let's run this. So this is going to give us, can somebody tell us how many rows we are expecting here?
7
I said,
rows.
I wanted this to be interactive. So please help. 7, yeah. So let's execute it and see whether we'll get 7. Yeah, we have 7 rows. We have 7 rows of data. Right. Now let's use another table so that we have some flexibility. Let's use another table. Let's see what we have under the training table. I don't know if this would open it up. Training. Okay, let me call the training table. Select. Let me call this query number 2. So all this is our first query 1, right? Query 1, this is query 2. Different versions of query 1. And let's see query 2. Select. All from training. From the training table. That's what we want. Just to have some variety. Right, so this is the training table we have. Right. I remember when I did this the last time, I made mention of the use of the word distinct. Use of distinct. This distinct. Use of distinct. So that would give us our query number 3. We're going to use this distinct in this table because of how this is structured. Now, we see here that course ID, for example, appears several times. Course ID 1111. And if you scroll down, you would see, in fact, even training ID, no, training ID is quite unique, but course ID has a lot of redundancy. So why do we have to do that? Let's see. Before we do that, let's see what happens if we select a particular column. Select course ID. We are interested here in course ID. From training. So if we run this here, it gives us just the training column. It gives us just the training column. The course ID column. But it doesn't tell us much. It just tells us that it just gives 1111, which doesn't really make so much sense. How many ones do we want to have? How many twos do we want to have? So does it mean that this course ID is not the same as that? It's not the same as that? No, we can't represent data like this. So we need to streamline it so that we have one value for one course. So that is where the word distinct comes in. So select distinct, course ID. From training. And if we execute this, let's see what happens. So it streamlined the whole thing. There are 7 courses. We see exactly the number of courses that there are. Each one, this is course ID 1, 2. So we know from this that there are 7 courses offered by the institution or whatever, offered by Blue Sky Citadel. Right. So this is where we use the word, we use the distinct word.
Sorry, Horsey, where are all the tables you created? Where have they gone?
As I run, they just
disappear.
Yeah.
Okay, so if you want to go back to them, is there any way of doing that?
Oh, I just run them again.
Oh, okay.
So if I were to run this again, I get the table, and if I need the table, I just copy and paste. This gives me that.
Okay. Okay.
Please, can I ask, is it possible for us to also have this table so that we can go along with you?
That is the idea. That is why I thought I could. I'm also still learning, actually. So I've asked the Abibala to create a table for us that we can all share. A database, this thing, so that we can all use. Right. So maybe in the next week or 2, we would have a table that we can all use.
Excuse me.
Yeah.
Please, what about the framework? How to download it, the links?
You mean the server?
Yes, please.
There are a number of servers. My SQL is one, No SQL is another.
I mean, this particular one that you are using to train us.
Yeah.
Can you send me the link so that I can download
It is the Microsoft SQL Server. However, it will not have these tables in there. These tables are created and then created within the database of the server. So let me find out if I can send it to you, right? But we are working to get a database that we can all share.
Okay.
This is like a borrowed database that I'm using.
Okay.
Right. So somebody said, where have the tables gone to? So you now see that it's not one, if you have the most important thing is to understand how to write the queries, which as you can see is quite straightforward. This is why I'm starting right from scratch. So that's the most important. So long as you understand how to query the database, you can query any database, regardless. It wouldn't matter at all what is in it. You will be able to query it. Right, so let's go. Let's choose another table. I think the table I have in mind now is the pay elements, because I want us to run some calculation on that table. But before we do that, let's see what is in there. So select all. Where do we want to take it from? From pay elements. Now, the reason why I've chosen this is because I want us to see if we can run some calculations on this, because we can only do calculations on figures, isn't it? So select from pay elements. Pay elements. Select all from pay elements. Let's see what is inside that table. Right, so this is what we have. We have pay element ID, person ID, job ID, start date, end date, pay type, pay value, date, and date modified. Let's see if we can just choose a few of these. Select pay element ID, pay element ID, pay element ID. When you are selecting this way, there should be a comma after each of the table headers. Person ID, person ID, and pay value. And you want to take that from your pay elements. So if we run this, oh God, have mercy. So this is all we are interested in at this point. Let's see what would happen. Can we make a calculation on this? Can we make any calculation on this pay value? Let's see. This, I believe, is annual salary, right? Let's see if we can calculate the monthly salary. So let's see if we can calculate monthly salary from here. To get the monthly salary, what do? We take this pay value and divide it by 12. That's the pay value. That's a yearly salary. We are not interested in this. We'll cut this off in a bit. That is hourly rates. If you look at the other table, if you look at this one, you see that there is hourly rates. These are hourly rates here. But not to worry, just get the idea. The whole point here is for us to get the idea of how to run these things. So what we want to do is to get the pay value divided by 12. That gives us the monthly salary. If we were to run this, we have that. Again, forget about these ones here. Just focus. Let's focus on this here. And this says no column name. But in other SQL databases, this will just take the column number. So instead of saying no column name, it will tell us column 1, 2, 3, 4. This will be column 4. Right? Now let's see how we can assign a name to this. Let's see how we can assign a name to this no column name. All you do, the table that has no name, you can decide to give it a name. Remember, I said there are user-defined names. So you decide to call it as monthly salary. Monthly salary. And if you run this now, this is what you would have. The no column name has changed to monthly salary. But because, let me just make this lowercase to make everything look the same. So let me just make this lowercase to make everything look the same. Are we getting somewhere? Any questions so far? Okay. I'm going to leave this bit. I'll come back here after I have made another introduction. I'll come back to the same table. I'll come back to this table in a bit. I just want to explain a few things before I come back to it. And what I want to explain is how to verify the literals that I spoke about. Verifying literals. To do that, let me just run this again so that we see what we have there. Or no, let me come back to this. I'll come back to this because I need to use a word that I haven't explained yet. So I'll come back to it. This is the where clause. Remember, we said one of the words when we doing remember this word here? The where, which filters the rules, where. I mentioned that earlier on. Though I said it's not one of the mandatory words, but yeah, as and when needed, it is used. So let's see a use of this within this context. So the where clause. Now, when we need to restrict the rules produced from a select statement, this is when we use the where clause. This would normally be followed by a search condition. So when we need to restrict, so the where clause is used to restrict the rules produced from a select. Why am I even typing everything in caps? Statement. Right. So let's see. Let me just do this. Let me do this to put everything under. I'm not sure if are we all familiar with this? I believe we are all familiar with that, especially the QAC here. We should be familiar with that. We use it as to make comments in our automation and everything. It's used as a comment symbol in computing mainly. So there are 5 basic search conditions. We said the where clause is used in a search condition to restrict the number of rules produced. There are 5 basic search conditions. Now, the first one is the comparison condition. Now, what is the comparison condition? This is where the value of one expression is compared to another. The value of one expression is compared to another. For example, We say A is equal to B. It's a comparison. We say C is greater than D. It's a comparison. We say V is not equal to Y. V is not equal to Y. It's a comparison. So these are comparison expressions, right? So straight away, you are seeing certain comparison words that we use: equal to, and not equal to, greater than, less than, greater than or equal to, less than or equal to. All these are comparison statements. So the where clause is used for comparison. That's the first point, the first thing we will talk about. It is also used in a range. So the where clause is used in testing whether a value or an expression falls within a specified range. Whether it falls within a specified range. Example, let's see, let me see, range. I actually don't need this again here. It's already taken care of. Range. Example, we say that V is between let me use figures. We say 300 is between 400 and 200. That statement is true, isn't it? So this is used in specifying, the where condition is also used as a range condition. It is used to set membership. As a set membership. Set membership. For example, if I tell you that from a table, find names of all people who are managers. So that's a membership, a group of people, a group of things. So that you can use a where condition also there to define or declare membership. We can also use it in pattern matching. Pattern matching. Now, this tests whether one pattern, one string matches another. I would explain this as we go along. And it also tests whether a field is null or not. To test for null values. So this is where we use, these are the conditions under which we use the where clause for comparisons, for range assertions, testing of membership, pattern matching, and null. Now, this word null here, one must be very, very careful with it when we are dealing with null. And I would explain as we go on why. Because can anyone tell you what null really means?
No information,
Zero value.
zero value.
And zero value is actually something. So zero is not null. The first person was very close.
Okay.
The first person who spoke was very, very close. Now it simply means that the value is not known. We don't know what it is. So when testing for null, we need to have a good understanding of it so that we know exactly what we are doing. Right, so let's see. If we say we should select, let's go back to the first one. So let's take query 5.1. That is our comparison, right? Comparison search. If we, for example, say we should select from the pay values, the pay table, we should select from the pay elements all persons or all people whose pay is above a certain value. That's a comparison. So for example, let's say select from, let's go back to that statement. I said we will come back to that table. So let's copy this one and put it back there. And then run it and see what we get. If we run this, we know what we have there. Okay. So these are, again, let's for now just focus on the annual figures rather than the hourly ones. If we say we want to get people whose salaries are, for example, 30,000 and above, or 40,000 and above, what do we do? Select from this. Now you see that the salaries are under a column called pay value. So that is what you are interested in here. So select from the pay elements where pay value is greater than 30,000. Let's run this and see what we get. This is what we get. Now we see that each of these is greater than 30,000. Each of these is greater than 30,000. If we were to choose any figure, can someone mention any figure there? Let's see if we are not sleeping.
Greater than 50,000.
50,000. Let's try. Let's see if 50,000 will produce anything.
Just one value.
Execute.
Yeah, we have one. This person must be the boss. So yeah, it gives us something, right? So basically that's how we can do this. Now the comparison search can also be done on multiple columns, not just one. So let's see. We call this the compound comparison set. Compound comparison set. So we go back here, select, just to make it easy. Select select from pay elements where pay value is, let me use this. Let me go back to my 30,000. Or what other table, what other column do we have there? End date. Let me use end date. End date. End date is it coming up? Or end date. End date is not null. Is not null. End date is not null. This means end date is not null. This sign here says end date is not null. If we run this, what do we have? This is what we have. Any questions here?
Yes, I do.
Yeah, I was
Okay, so-
expecting it.
Yeah, so when you said is not null, but
Mhm.
it's actually giving us information with. I mean,
Beautiful. I was actually expecting that question. See this word here, or.
yes,
What does it mean? It's either this or that. It is not
Right.
and.
yes, yeah.
Yeah. So that's where the difference is. So I was actually ready. I was expecting that question actually.
So if you put and, it's not going to give us any result.
Let's try that actually. Let's try it and see. Let's try it and see. We might just. Do we get it?
Yes.
Yeah.
Yes.
Right. Now let's do another one. Actually, another, if we use or to be the same thing, and is no. This or that, this and that. Let me use and here. Let's see what we get here. Same thing. Is pay value is this, and end date is that. This also doesn't give us anything because there's nothing like that in the table. There's nothing like, let's use or and see what would happen there. So you see, or gives us something. Right. Let's try another one. Let's try another column, just so we don't, we have some flexibility. Another, let's see, job ID. Job ID. Job ID is greater than 6. Where job ID is greater than 6. That gives us that. All of this. So you see that job ID here for everything would be, this is also all. So it produces almost everything. But if we were to use and, this is what we have. So these are the persons who earn 30,000 or more, and their job IDs are, they have job IDs greater than 6. So probably these are the senior management job IDs, right? Now let's look at the next range, the next condition, the range condition. This is between and not between. Between and not between. So let's see. If we are to, for example, list all staff with pay value between a certain level, list all staff. Pay between, let's say 40,000 and 60,000. Then what do we do? Between 40,000 and 60,000. Again, we go to our select. Where pay value. Pay value between 40,000 and 60,000. Let's run that and see what happens. These are the people we have with values, salaries between 40 and 60,000. 40 and 60,000, 3 people. Now, let's also bear in mind that when we use the word between and not between, the endpoints are inclusive in the argument. So if there was a 40,000 pay here, it would have appeared. If there was 60, it would have appeared. So the endpoints are inclusive. And the same thing, if we use the not between, then the outside range are also inclusive in the result. So that if we were to say that, let's run that. Let's run the count, the opposite of this. Not between. This is what we have. This is what we have. Right, let's make progress. The third one, I think, is what? Is set membership, isn't it? The third one is set membership. Yep, set membership. So let's see what we can do with that. Now to do this, I'm going to use a different table just so we have some variety. I'm going to use the marital status table so that we have some variety. But before we use that condition, let's see. So this is set membership. Set membership search. Condition. And this simply means that something is either included in a group or it is not in a group. That is simply what it means. You are either a member of a group or you are not a member of a group. So that is simply what this means. So let's see, select all from, what's this called? Was it, this table is called marital status. Marital status. Let's select all of this and see what we have. We have married, separated, divorced, cohabiting, single, married, separated, divorced, cohabiting, single, all of that. So we have how many? About 4 different status there. Right. So let's see how we can write a query to show whether somebody belongs to a group or not. So where marital status in This has to be in quote and in brackets. Now, how is this written here? Mind you, remember the literals that we spoke about? It has to be written exactly as it is here. So let's see, let's say I write it like this, and let's see whether it would show. Married. So there are two errors here straight away. Okay, let me even write it like this and see. The error hasn't gone. I know why the error hasn't gone, but I just want to try to see if we can run it like that. Simply, it's not going to allow us because it is a literal. It has to be written exactly the way it is in the table. Then also literal string literals must be in quotes, in single quotes. So this has to have that and has to have that. So now you see that the red underline is gone. And if we run this, it will run perfectly. So all these are the married people in the business. These are the married people in the business. Now we can do this on more than one column. We can have more than one column here. What else should we choose? Let's run this again and see what we can choose. I want someone to choose something that we can pair with married.
Widowed.
Single.
If they are widowed, are they still okay? They could have been married. They are widowed. Okay, let's try that and see. Somebody said widowed. Let's try it. So this comes here, and then we have widowed. Does it start with a capital? Let's check to see if it starts with capital. I'm sure it would. Yep. So let's. What's happening here? Hey, come on. Widowed. Does someone notice any error? And can
Yes.
someone tell us why the error is there?
It's not in quotation marks.
Beautiful. Thank you so much. So if we run this, let's see. Yep, it gives us all the married people and gives us the widowed ones as well. And we can run multiple ones like that. Let's use cohabit. Yep, another one. Did I spell this wrongly? Let me check. Cohabit. Okay, cohabiting. So you see that it didn't show cohabiting. So that's what it should be, cohabiting. Cohabiting. Is it double T or one T? Cohabiting, one T. Now, if we run it, we should have a different result. This is what we have. Right. Another one. Let's go on. Let's make progress. I hope we would finish before 9:30. Query 5.4.
Sorry, before you move ahead, can I quickly clarify something with you?
Yes, please.
So can I please get you to scroll up a bit? Yeah, I need to see where you queried null.
Pardon?
I just want to see where you queried null. Just go up a bit, go up a bit more, a bit more, a bit more. Yeah, there. Right. So I was just thinking about what you said regarding when it's literal, you have to put it in quote. So I'm just thinking, is this null not literal, or what
No,
is it not literal?
it's not literal.
Okay.
It's a word in SQL.
Right.
Yeah.
Okay.
All right. So let's just go on quickly. The next we would do is the pattern match. That's quite a long one, actually. Pattern match. Pattern match. Pattern match search. Now, this is a case where something is like another. Like or not like. It follows a certain pattern. It is like something or it is not like something. So that is the case we have to look at now. But before we do this, because it's a pattern and we're dealing with strings, usually when we have a pattern match, it may not be specific. It's a pattern, so it's not something that could be specific. It's maybe it looks like, but not necessarily the exact same thing. So we use the wildcard symbol to describe the pattern match search. I don't know if anyone knows what a wildcard symbol is. Anyone?
Yes.
Yep. Can you tell us, please?
I think, to be honest, I can't really explain. But I know when you are trying to search for something, maybe you put percentage or at the front.
That's correct. That's all I want. That's all I want. Thank you very much. So let me just put all of these in one Let me just put all of these in so that I don't have to be typing this.
But she didn't explain to us what that was about.
Pardon?
We didn't get the explanation.
Oh, you
just
didn't get it.
percentage and that
Oh
was it.
yeah, the percentage is a wild card. It's called a wild card. It is used. Okay, let's go on. You would understand what it means, right?
Okay, thank you.
Can you also include underscore as the white card?
Yes, please. Thank you.
Yeah.
I was coming to. It's actually on my mind. I'll come to that too.
All right.
So let's look at instances of the wild card. I'm going to give us about 1, 2, 3, 4, about 4 instances of the wild card, and then we have just one instance of the underscore. So let's look at it. We would use the address table. Where is that? The address table. So let's first call the address table so that we see what is under the address table. Something is disturbing my screen. How did I get this here? How can I get rid of this? Anyway, let me see if it will allow, yeah, as long as it allows me to go on, that's fine. So let's select all from addresses table. So these are the addresses we have from in the addresses table. So let's see. It's like a wild goose chase, isn't it? Right. But let me just give some examples of what we want to do here. 1. When we have instances like so these are also literals, so they must be in quotes. Now, what this means, H percentage, right? H percentage. What this means is that the first character must be H. The rest can be anything. The first character that you are looking for must be an H. The rest can be anything. So the opposite of that would be what? If we have something like B. Who can tell us what this would mean, given the explanation I gave for that?
That means anything that have B as the second letter.
Right. So this simply means that anything but the last character must be a B. The last character must be a B. Any character of any sequence of characters of any length with the last one being a B. That is what it means. What is happening to my caps? Like, now let's see this one. That for Can anyone tell us what this would mean? Can anyone tell us what this would mean? Any sequence of characters, but there must be that Ford in the characters. That Ford must be within the characters. It must be there. So if we have not like, what will this mean?
Will not have a character with P.
No.
Must not have character letter P starting it.
That's the correct thing. Yeah. The first character cannot be a P. The first character cannot be a P. And also somebody mentioned the underscore. Where is it? Underscore. So in that instance, we can have something like okay. Can anyone tell us what this would mean? No, I haven't finished actually. Sorry, I haven't finished that. Yeah, so that is it. Now, what this simply means is that this literal here must start with a K, but must have 1, 2, 3, 4, 5 characters. That is what it means. It must have 5 characters in the string. And the first must be a K. So if we were to flip it, sorry. Then this one must have what? Still, okay, let me take one off. 1, 2, 3, 4, 4 characters. The last must be a Z. Right, the last must be a Z. So that's what we have here. Okay, so let's go here and then see how we can use this in this database. Let's see how we can use this in this database. Let's look at the address. So we're looking at addresses. Can we use this somewhere within the address table? I think let's look at line 4 for it. Let's take line 4, the one before the postcode, and just see. Okay, let me choose Middlesex. Let's choose Middlesex. Let's see what would happen if we were to run a query. Say we want all addresses that contain Middlesex. So what do? Select from. Select from addresses. Oh no. Okay. This is the color of this. Who can tell us why this is still like this? If I were to run this now, it will not execute. Let's see, it will not execute. Wow, it has. It shouldn't. I don't know why it did. Now, simply because this is commented out. So we should end the comments here before we can run this. You see that it has changed. And if we run it, I'm surprised it actually run actually. Right, so let me take this out as well. So here we say where address. We're looking at the pattern. Where address, where do we have Middlesex? In line 4. So where address, line 4. Like Middlesex. Middlesex, is it? Okay, lowercase Middlesex. Middlesex. If we run this, what do we have? We only have addresses containing Middlesex. Yeah, we have all addresses containing Middlesex. Right. The last one is the null that I want to deal with. I think we have 15 minutes left. But before I do that, let me quickly verify. I did say that I was going to verify literals. So let's do that before we do the null. So let's see. How do we get to show that we need to specify things the way they should be done? Let's go back to the employee table, to the employee pay table. Where is the pay table? Paid from, okay, let me copy that. Let me just copy that. And then bring it back here. If I run this, it will run. Normally, we know that already. So if we decide to select something from just anything, let's say salary. Okay, let me run it again. Let's look at this one here. If we were to say, for example, that where pay type, pay type, pay type is equal to salaried. Salaried. This is literal, so we need to put it in quotes. If we run it, it would only give us those with salaries. All those with hourly rates are cut off. However, if we were to make the mistake of spelling this any other way, other than what is in the table, okay, let's run this one here and see what happens. Nothing. It doesn't give us anything because this is not in the table. This is not in the table, so we get nothing. It doesn't matter how we run it. It doesn't matter how we specify it. If we were to do this as a capital, it wouldn't run. Hey, what's happening? Maybe certain things have changed. Salaried. Okay, maybe modern systems know they've changed these things, they can recognize them, but I wasn't expecting it to run actually. If we write it as salary, let's see if we write it as salary, whether that would work. Salary. That also didn't work.
Can we capitalize the entire salaried?
Okay, let's try that and see. I'm actually surprised this one ran because I wasn't expecting it to. Salaried. Okay, so it doesn't matter, the spelling doesn't, the capitalization doesn't matter. Actually, I've just learned that. It's new to me now, actually. That's new to me. So we are all learning. Right, now let's go to the last thing that we want to do, the null condition. I think we should be able to finish by 10 o'clock. Null search, query 5.5. Is null or is not null? Is null or is not null? Which table can we use for this? We will still use the pay table. So let's see if we can quickly select